Yeah, so the laser comes in through here, and this other one comes down through here, and it'll shine down this way. And then here's my photodetector at the bottom, and I use that to measure stuff about the cell. And so the signal's coming through here and into the computer where I process them. The same technology as MRI. And so essentially what we do is we've got a coil and we run a current through it. It makes a magnetic field. We've got a bunch of spins, so they tilt and then they precess about the big magnetic field.
I want to tell them what a spin is.
No, it's not important. So it's like a tiny bar magnet. So we get a bunch of tiny bar magnets and we tilt them, and then they'll precess about the big magnetic field, and that produces an oscillating signal that we detect using this spectrometer.
It's not oscillating right now.
No.
It's not oscillating right now, of course, since it's all off.
It's oscillating.
But then we do some math to it, and we get out a spectrum here, and so we can. This means that we get oscillation at this frequency, and so this green signal is when we take one of the cells and just stick it in the magnetic field and do this NMR on it. But then, if we turn on a laser and shine it at just the right frequency, then we can multiply the signal by about a factor of 7, 8, something like that. And then if we tune to a different frequency of the laser, we can actually reverse the signal so that the bar magnets or the spins will be aligned in the opposite direction. So the neat thing about that is we can use a laser to align these spins in a solid. Okay, and so normally when you do MRI images, that's you're taking a picture of hydrogen in the water in your body. And so one technique that they've developed in our group a couple of years ago was instead of detecting water in your body, you breathe in polarized xenon or helium gas, and then they can take an image of the inside of your lungs using MRI technology. And that's done using lasers and stuff, technology that we sort of started developing here. And so the next step then is to try and polarize solids. And so then you could, imagine scenarios where you inject stuff and then you can image things that take a lot longer to occur than breathing.
And less invasive.
Yeah. So that's sort of the magic of MRI, is that it's non-invasive and you can diagnose a lot of neat stuff.